Welcome to Supercar. If you've ever wondered about the mysterious force that moves your vehicle, you're in the right place. We're about to demystify the heart of your car, the engine, and reveal the ingenious secret behind the four-stroke cycle. Hit that subscribe button and ring the notification bell, because you won't want to miss our next deep dive into automotive tech. Have you ever stopped to think about how a simple liquid, gasoline, transforms into the kinetic energy that pushes a ton of metal down the road? It's all thanks to the engine's job converting chemical energy from fuel into mechanical work. The process is a rapid, controlled series of tiny explosions occurring inside the engine's cylinders. This conversion process is known as internal combustion, and the most common method used today is the four-stroke cycle, invented by Nikolaus Otto. Before we dive into the four strokes, let's look at the key components involved: the cylinder block, the piston, the connecting rod, and the crankshaft. Imagine the engine as a stage. The cylinder is the performance arena, sealed at the top by the cylinder head, which houses the intake and exhaust valves and the spark plug. The piston moves up and down inside the cylinder like a plunger. This motion is transferred through the connecting rod to the crankshaft, which is essentially a cleverly shaped axle. The linear, up and down motion of the piston is converted by the crankshaft into the rotary motion that ultimately turns your wheels. Now that we know the players, let's explore the four crucial acts of the cycle. The car can't run without fuel and air, so how does the engine get its first breath? The cycle begins with the intake stroke. The intake valve opens, while the exhaust valve remains closed. As the piston moves down from the top of the cylinder, or top dead center, it creates a partial vacuum. This vacuum pulls the precisely mixed blend of air and fuel, the air-fuel mixture, through the open intake valve and into the cylinder. This is the engine drawing in the ingredients it needs to create power, much like you take a deep breath before exertion. This piston movement from top dead center to bottom dead center completes the first stroke. Why is squeezing the air and fuel so important for maximizing power? Once the cylinder is filled, we move to the compression stroke. Both the intake and exhaust valves snap shut, sealing the combustion chamber. The piston now moves up from bottom dead center, back toward top dead center, violently squeezing the air-fuel mixture into a much smaller space. This compression serves two vital purposes. First, it significantly raises the temperature of the mixture, making it more combustible. And second, it increases the density of the charge, which allows for a much more powerful energy release in the next step. The efficiency of your engine is directly related to how well it can perform this squeeze. This is the moment of truth. How does a tiny spark unleash so much power? Right as the piston reaches the very top of the compression stroke, the most dramatic part of the cycle begins. The power stroke. The spark plug fires, igniting the highly compressed and superheated air-fuel mixture. The resulting rapid explosion forces the piston violently down the cylinder. This is the power that is generated. It's the only stroke of the four that actually produces usable work. The force exerted on the piston drives the connecting rod, powerfully rotating the crankshaft. This rotational force is what drives the flywheel, and eventually, your car's wheels. What happens to the waste gases after the powerful explosion, and why must they be removed? The final act is the exhaust stroke, which is essential for preparing the cylinder for the next cycle. The exhaust valve opens, and the piston moves up again, pushing the spent, burnt gases, the byproducts of combustion, out of the cylinder and into the exhaust manifold, where they eventually exit through the tailpipe. Once the piston reaches TDC, the exhaust valve closes, the intake valve opens, and the entire four-stroke cycle, intake, compression, power, exhaust, begins again, thousands of times per minute. If a single cylinder only produces power on one of the four strokes, how does the engine keep running smoothly? The secret to a car's continuous smooth power delivery lies in having multiple cylinders. In a typical four-cylinder engine, the cycles are staggered. While one cylinder is in the power stroke, another is in the intake stroke, another in compression, and the last in exhaust. This precise timing ensures that a power stroke is always happening somewhere in the engine, providing a constant, flowing rotation to the crankshaft. This synchronization, managed by the timing belt or chain connecting the crankshaft to the camshafts, which operate the valves, is the ultimate secret to your engine's reliable performance. From a simple piston movement to the synchronized ballet of a multi-cylinder engine, the four-stroke cycle is a masterpiece of engineering. It's the reason a small amount of fuel can propel you thousands of miles. The next time you turn the key, remember the tiny, controlled explosions happening right under your hood. What part of the engine do you want us to break down next? The turbocharger, the transmission, or maybe the differential? Let us know in the comments below. If you found this explanation helpful, give us a thumbs up and subscribe to Supercar for more amazing automotive breakdowns.
With